Welcome, everybody. We're going to talk about two different chips from Yak, who needs no introduction. You wanted us just take it away, Yak?
Sure. Can you see my screen?
I can.
Awesome. So, hello everyone. Uh, Today I'm introducing two chips describing two decentralized applications, which I've been working and refining for a while. So I'm very excited to see these chips going. For some context, uh, a little over a year ago, I introduced a series of posts that addressed uh, something I call the problem of uniqueness on Chia. And the summary is that we there was no technique to have for the decentralized applications on Chia to have some capabilities that turned out to be quite important. Um, and really, what this resulted in is this chip with action layer and slots, that chip 50, also in review. Um, and uh, yeah, I guess a brief introduction to slots, what they are. As you know, if you have a decentralized application on Chia, you can have a singleton, which basically gives a series of coins an identity. So if you have an NFT, every time you spend it, you create a new coin because you can spend a coin only once. But the identity of the NFT remains in that coin because it's a singleton. Uh, that's similar with decentralized apps. So every time you transact with the TBAT pool, a coin is spent and a new one is created. And that coin doesn't track metadata, but rather it tracks data relevant to the pool. So for example, how many assets it has, how much liquidity, tokens it minted, and other data it uses. Slots are a way not to keep the data in the coin itself, which increases cost a lot. So tracking state works if you have, for example, 5 values that you access with every spend and you update them. But if you want to go up to, say, 100,000 values, revealing them every time and processing them becomes really expensive. So slots are kind of some nodes that one coin leaves a feature version of itself. So what happens is, for example, someone deposits 5 tokens in the reward distributor. The singleton will make this node, and then whenever you want to withdraw, you find this node on the blockchain, you pass it to the singleton, you say, hey, I have this ticket, which is the slot, I want my tokens back, plus all the rewards I earned. And then when you spend the DApp, and then the DApp will know to verify that the node was not forged, it was created by the same singleton, and then do the action. Um, this is really powerful because it's equivalent to Ethereum mappings, or other programming languages call them hash maps or dictionaries. So now you have a lot more possibilities. And going back to today's chips, uh, really, uh, this technique of slots was developed for XCHandles, where the problem of uniqueness is having a name. How do you prove that name hasn't been registered before? Now, I know in the context of the Ethereum name service or Solana name service or whatever, these are usually called names. In the context of XCH handles, they're called handles. But these are pieces of string that can identify on the blockchain. So for example, you have @yak, and it will get resolved to my identity. Um, so uh, I will, uh, the details of how you ensure uniqueness are in the chip. Uh, it's basically creating kind of a sorted list, and then users search the entries of that list. And if you have two values and you can insert your name while keeping the list sorted, then you know that name hasn't been registered before. So in a way, by using this nodes to the feature singleton, plus searching off-chain and then only presenting the result on the blockchain where it's verifiable, you offload the complex part off-chain while maintaining a completely decentralized way to prove a handle hasn't been registered before. Catalog is very similar. So if handles is a way of maintaining identity, and I'll get to it a bit later, catalog is a public database of maintaining cat identities, so cat details. The idea is that if you have a token, you'd go and register it on chain, and as the owner, you receive back an NFT which gives you access to the cat entry. So then if you want to, say, change the token's image, you can use this NFT and update it. And because it's on-chain and public, everyone would see it. And your alarms might be going a bit off because you need some moderation, at least for cat details. But once again, I'm going to come back to that a bit later. Next, let me just try to move this bar I see here a bit. Perfect. Okay, I guess, well, we should start going through the chips. So as taking a step further, taking a step back, why do we need an identity service anyway? Well, because if you have a Chia address, while it contains a lot of information, to you it's a very long piece of random characters that you have to copy from place to place. So if someone, I don't know, sends me an address on Messenger on my phone, then I have to do some gymnastics to get it on my desktop where my wallet is. And these addresses, because they come from a hash, and they were really not necessarily designed to be very easy to use. They are hard to recognize. So you might, for example, try to remember that if an address starts with AAB, it belongs to someone, but then someone else can create an address that also starts with AAB, and that's actually a very common attack vector on Ethereum. It's hard to visually compare addresses, so to kind of differentiate between two addresses because they're so long and they have random characters. And they're also hard to type. So if I get it on my phone, I don't even think about trying to transcribe it on my computer. I'll probably use email or another service to transfer it to my computer and then paste it into the wallet. Now, as for rationale, I guess the first point I would like to address is it's a critique that is probably the most popular, which is why are handles, why do they need to be renewed every year? So going back, if the first version of the service that you could design if you wanted was best for the user is you just give handles for free to whoever comes first. But that poses a problem in the long term because people are seeking profit all the time. So what will happen if you have no cost for registration whatsoever is someone will come in, they'll register all the popular words, then they'll start registering the 2-letter handles, then the 4-letter handles, and so on your service, and then they'll try to sell them for profit. So actually designing a fair registration system has this problem of balancing how do you disincentivize people that will try to profit by being first to have access to the service versus how do you not get a service that's too expensive for everyone to use. Obviously, the next logical progression is to have a one-time registration fee, and that will indeed make it very expensive for someone to register as many handles as they want. The problem there is that once they pay the cost, the handle remains theirs forever. So kind of the cost doesn't depend on the time they own the handle. And that will not generate a lot of problems short term, likely. But looking in the longer term, it probably will. because they have no incentive now to let the handle go. So I think I should have a presentation around here, or maybe I closed it. Let's see. No. Okay. I seem to have uh, closed the tab with the slide I was looking for. But the idea is that if you look at my Twitter, I actually wanted to register the handle Yakuhito, but it turns out this account that was 5 years, that had 5 years with no activity previously, they used the handle Yakuhito, so I had to choose another one. Now they weren't using it anymore, and I think if you want an address book, the entries should be somewhat fluid. If there is a better use for the handle and the original owner just happened to disappear, there should be a way to redistribute the handles. Otherwise, over time, you're just getting more and more complicated handles, um, and because all the good ones are taken and then eventually abandoned, as the system is dynamic. And it has the chance of getting to a point where handles are a bit complicated and akin to addresses in that respect, where they start being long or they start being a bit less intuitive. Now, the other option, there's also another option to incentivize people freeing handles when they no longer need them, which is you take a static deposit and then you return it when the people don't use the handle anymore. This approach, I don't see it working because now you've removed the cost of owning the handle. So if I know I will get 100% back if I turn the handle back, well, I might also make more than 100% by selling the handle. So what could happen is this person with a lot of funds, they come and they park all the funds by registering very popular handles. So they register words, short handles all over again, and they try to sell them. And if at any point they actually need those funds, they can just deregister the handles and get their deposits back. So I think that's also not a very valuable design because one could argue the opportunist who does this attack uh, loses potential interest, but it's a lot less than the cost they pay for handles. And for that reason, XCHandles, as it is in this chip, will take yearly fees as opposed to one time or making handles free. Now, I should mention this is true for the main registry. And actually, the pricing logic is encoded in these puzzles that are set at launch. So sub-registries might have different logic. For example, one of the pieces of feedback I received was, could we make a sub-registry that just requires a ping? So you pay one time and then you ping every year. And I think that approach still has a few drawbacks, but with a custom pricing puzzle, you could do that for your own sub-registry. I guess I should also address feedback. When I made the post a year ago, as I mentioned, I already had the prototype. Since then, the designs for both XCHandles and catalog has been reviewed by a lot of community members in private when I explained it and I asked for feedback, and there have been major redesigns. I guess another piece of feedback was that you can't really price handles in XCH. And at first, I wanted the system to be as decentralized as humanly possible. And that meant pricing handles in XCH and then kind of following the block reward schedule. The problem is that with that, you lose a lot of opportunity to price handles as they should, because XCH price is inherently a lot more volatile. One XCH, the buying power of one XCH can vary a lot. And just one example, let's say I set the price of a handle to 1 XCH, and then the price gets to $100. Now handles are unaffordable for most users, very likely. Likewise, what if before the next halving, the price is half? Now handles, the price for handles is half, and that means kind of the anti-spam protection is also worse, just because the price was allowed to go too low. So for this reason, what's happening instead in registries is that pricing is done in warped USDC from base. And there is the issuer of warped USDC, which is the warp.green bridge, has a multisig. They can update this asset in the future. So if there is a Chia native stablecoin, or maybe a very good and trusted method to determine the price of XCH on chain, then the multisig can come in and kind of do this upgrade. So the system, which is otherwise decentralized, can price the handles using the new asset, using the new asset or method. This is kind of an upgrade hatch, and otherwise it is a decentralized registry. The multisig can handle how prices are determined, so the amount, the logic for registrations, and the logic for renewals and expiry, which I'll get to a bit later. But they can't override registrations. So once you register, you know that the handle is yours for at least the registered amount, and you always have an option to extend according to the current pricing puzzle. The pricing algorithm, again, there's always the question how to fairly distribute handles, how to get the handle that how to get a handle to the person who most wants it. I think that's the best definition of fair. So with that logic, this pricing strategy that's implemented in the main registry, at least is proposed, is trying to see a few desirable features and then price the handle accordingly. So actually, you can also see this table in the docs. But what's happening here is the shorter the handle, the more people are likely to want it. So naturally, shorter handles will have a higher registration fee. Also, again, one piece of feedback was that if the handles contain numbers, they're likely not someone's first choice. So for example, when I register my Twitter handle, Yakuhito was my first choice. When I didn't have that, I replaced the I with 1 and the O with 0. So under this scheme, if you have a number in your handle, the price will be half what the price without a number is. And you have here a few examples and the expected price. Now, there is also the question of what do you do when someone fails to renew their handle? So they register it, they renew it for a time, or maybe they don't renew it at all, and then they reach expiration. If you have an expired handle that someone used, but they no longer paid for it, how do you distribute it to the person who wants it the most? And here, I think there's also the opportunity of learning from the Ethereum name service, which is probably the biggest blockchain identity provider with a lot of history. So they switched the mechanism to expire handles, to expire their names quite a lot of times. And XCHandles is using the latest version. So what's happening is that the handle kind of enters a reverse auction. So it starts with a really high price of, I think it's 100 million USDC from base. And obviously, no one is going to do that. But the purpose of this auction is not to generate a bid, on the 1st second, but to allow people to bid when the price reaches 100 million USDC. what they consider to be the handle's value. So this value, by the end of the first day, it will halve. It's going down exponentially. So by the end of the second day, the value from the end of the first day will also halve. So it will be 4 times as small. Then you go to 8 times and so on. By the end of the 28th day, there is no more premium to pay for the handle, so you only pay the normal price. So if let's say Yakuhito expires, it will be more expensive. It will be 10 USDC from base plus the premium for the first 4 weeks. But if no one bids in that reverse auction after 4 weeks, it will be available to register for 10 USDC, basically like it were a new handle. I covered the reasoning for pricing handles in USDC, but is written in the chip as well. Now, during launch, because this is a new handle system, it shouldn't, people that just try to register on the first second, because this algorithm that only checks on-chain data might not be accurate. So for example, it doesn't use the fact that handles could be words at all. There's kind of a secondary auction that only happens when the registry is launched. And that's inspired by the logic that happens when some top-level domains launch. So for example, when the .app domain launched, they had a strategy where the prices for all domains would be really high. And then, like the expiry mechanism, they will go down each day until after a while, all the domains started costing like their price now. So what will happen is at XCHandles launch, you'll have all these prices multiplied by a factor, which again, is really high on the first day. But the idea is that only those people that really, really want to handle will pay the registration price on the first day. It will then gradually lower after a few weeks. I think it's either 1 or 2 weeks, the time period is in the chip. Until after that, the launch ends and the price will remain this. And I think this pricing will remain so in the foreseeable future. Once again, if you have ideas about distribution or all this logic, please do reach out or leave comments in the chip. This is just the result of the feedback and research I've done so far, but as this is a chip, it's open for discussion. Now, I know we've talked quite a bit about handles, but probably it's better to get through the handles chip and then move on to the catalog chip. So diving a bit more into what the handles decentralized app does on-chain, the actioners are enumerated here. So as I mentioned, it can register a handle that hasn't been registered before. You can extend your registration. So if you have a handle and it expires in a few weeks, you might want to extend the registration for a year or more, and you can do that. You can update your handle. So if you want your handle to point to a new NFT, you can tell the registry and there's a process to update. So your handle is resolved to another NFT where you can put things such as your display name. Now, the registration action has 2 steps, which are first, you commit to registering a handle, and then after a number of blocks, you do the registration. And the reasoning for that is if it had only 1 step, you'd reveal the handle you registered in the public mempool. So someone could see I was trying to register yak.xch, and it would be possible for, say, a malicious farmer to register yak.xch, kind of ignore my transaction, register it themselves, and then try to sell me the handle I just tried to register for a bigger price. So this attack basically allows someone to have the knowledge that you want to handle, and then they're okay with registering it and then trying to sell at a higher price, because a lot of users would probably be likely to pay even a small premium. To prevent that, what's happening is that on chain you say, I want to register a handle, but the blockchain only has the hash of few details. So you don't actually know. It's hard to even say the coin is saying that you want to register a handle. And even if it were the data on chain, is kind of a very, very scrambled version of all the or your registration details. After 32 blocks passed, you do a second transaction revealing this data. And that's when you pay the registration, when the registration fee goes to the registry, but also when you receive your handle. So now someone seeing this, they can't register the handle anymore. They will need to do this first step first, then wait 32 blocks and do that. So if something happens in between, like 3 people do the first step for the same handle at the same time, and then one of them registers the handle, the other two shouldn't have their funds locked because there was no way of knowing other people registered the same handle. So this refund action is there to return the money when some very specific invalid registrations attempts were made. There is also a specific interaction where you get expired handles, and that goes back to the auction I talked about, because that, as you can imagine, uses a special pricing algorithm since the premium exponentially decays. And then there's kind of a helper function that's not currently used, but it's very nice for integration with decentralized apps, which is an oracle. So basically, if you have a handle, you can do this interaction, and then the XCHandles singleton will essentially shout the data about your handle to confirm it. And that's useful if other apps want to assert it on-chain. These posts here are the ones I talked about that I released last year. The documentation, I think the apps and logic behind them are very neatly documented in the official documentation. So here you have some FAQ, which covers the basics and things for users. But if you want to find more about XCHandles, you can actually go here under technical manual. And then there's a lot of explanations for every action. There's some description and links to both the source code and yeah. Now, going on to what a handle is, it currently is represented by an NFT. So the way it works, you register your handle, which is a piece of string, and then that resolves to an NFT you have in your wallet. And with that NFT, you can set properties. So for example, if you hold the NFT to your wallet, if someone tries to send money to your handle, the idea is that the wallet in the background will resolve the handle to the NFT and then the NFT to its owner's address. So when you actually send, I don't know, XCH to Yak, the wallet will do all that work, figure out the destination address, and then send them. You can also set a display name. So if sites support handles how you want your name to appear, or for example, you can set a profile image that will show up both for the NFT, but also when you log into a website that support that. As I briefly mentioned, there's the main registry. Handles, you need to have a registry to ensure uniqueness. So in a given registry, handles are unique. You can't register Yak twice in the same registry. Now there's the main XCHandles registry, which has all the pricing logic I talked about, for example. But there might be sub-registries. And how this works is that you'd probably refer to handles as this special format. So in this case, someone registered a handle at registry in the main registry. And that points, instead of an NFT, it points to another registry where other people can register a handle. And this is useful, for example, for dig network. So if they had the dig entry in the main registry, you could just do add dig and then any dig website name, and then um, the software responsible for interpreting this would first resolve dig, and then it will look into that subregistry and resolve the new handle. And that's useful because you want the ability to have other registries operated using different logic. So for example, dig might price their handles in dig and have another renewal logic. This is the pricing factor. So I wasn't sure beforehand, but handles will start off very, very expensive on the first day, but then this factor decreases every day, every 24 hours, until after 2 weeks, the multiplier is 1x. So all handles will be priced according to the strategy here. In terms of tests, I think I should also mention there a lot of the code. If you go, okay, I managed to move this Zoom screen. Sorry for that. GitHub.com. This was the original repository. And right now, I apologize for the light mode. It's an incognito tab. But this repository contains the code, but also drivers and a CLI for both catalog and XCHandles. So this primitives, several versions of both registries have been tested on testnet and also through tests that test each interaction and make sure everything works as intended. The testing code and drivers have been moved to the Chia Wallet SDK. So if you are looking for those, you should check out the Chia Wallet SDK in the XCH dev organization. Another, I would say the latest improvement was that everything has been rewritten in Ru as opposed to Chia Lisp. And that wasn't to modify functionality. The functionality of all the apps remained the same. It was just to compare the overall cost of the spans. So the idea is that if you have less cost, when there is fee pressure, transactions with the same priority will cost less in fees to go through. And after the comparison, there seems to be a very strong case for Ru, and the comparison itself, there's been a blog post which is linked in the chip, and there's also these comparisons for every single puzzle. It got smaller, and also when comparing interactions as a whole, there seems to be a reduction in overall cost. So the latest version of the puzzles is written in Ru, and I think it's nice if you want to review it because I also find it slightly easier to read if you are coming from other programming languages. The latest puzzles are currently going through another security review, and once that is complete, I will write that on the chip thread. I spoke about registration front running, so leaking of that information that you are interested in a handle and how handles that. Also, the multisig, it has limited control over the registry itself, but still it's the only centralized component. And if you plan to use warped USDC, I don't think it adds a lot more trust assumptions, but it's something to be aware of when evaluating this whole chip. If there are no questions, I'll move to catalog, but I also know that was a lot. So
Yeah, let's pause here for questions. Thanks, Yak. That was really good. Nobody?
I had one, but I forgot what it was.
Oh.
Um,
I have one. Uh, where does the money go when you register?
So it currently would go it, on the in the app. It's a predefined puzzle hash. It would go to my multisig. Uh, the idea is that by using a vault, you can upgrade in the future. So if say there's a DAO primitive, and it's decided that money should go to a DAO instead, you can upgrade the vault to be another singleton with custom logic, and that would handle the distribution of funds.
Okay, you should probably just add a little bit of info about that.
Yeah,
I think this chip is really well thought out. I mean, you've clearly gone through a lot of different scenarios here, so it looks very well
it's
done.
it's the combination of a lot of work and a lot of thought, because these are very complex apps. So there have been there have been many iterations on everything. Uh, I'm just presenting kind of the result of that and feedback.
Right. So this is drafted name only. Rigidity, did
I do
you?
have a question.
Oh, go ahead.
I do have a question regarding like front end for our developers or APIs around this. How would you expect this to be integrated into other systems? Is this more like a use coin set plus libraries, or do you expect like them to be centralized providers that provide this kind of information to wallets and other services?
Yeah, that's a fair question. So I think first the drivers will be in the Chia Wallet SDK. I think currently the previous version, which was tested and so on, is in Chia Wallet SDK, but that will be updated. I also see a place for central API, just because for handles, uh, for example, for registrations, you have to keep a list of all the available handles off chain, but still in memory. So either you can directly resolve data directly from the chain, and then you can use, as you said, CoinSet and the wallet SDK. Or if it's like a register action, another way to speed it up is having an API, and the API can also give you a proof. So you can check all the data the API is giving you. But that's just a way to speed things up. The drivers in Chia Wallet SDK, which will be used by the CLI as well, should give you enough data that if you had if you didn't care about time, you could do all operations on the registry. So you could resolve any handle, you could register new handles. But the API is a nice way to speed things up. And there's a way to give proofs for, say, slots, or when you resolve a handle through the API. So it's very fast because the API can cache handles. The API can give you a short proof, and then you verify the existence of a few coins on the blockchain, and you know the API returned up-to-date data. That's true.
I can imagine it just speeds up the adoption if there is like ready to uh, to use solutions like that instead of expecting people to use the SDK. Even though the SDK is very simple to integrate into a lot of places, it just speeds up adoption if such solutions already exist. It doesn't have to be you, but somebody should probably provide that.
Yeah, it will. The plan is for it to be publicly accessible, so there will be at least one instance. But also, all this code is under the MIT license and will be open sourced. Like all the code that's been written is already open sourced. But the plan is to open source everything. So even if I, who will probably be running the API for a while, disappear, someone can just take the code, set it up, and they can run it. I think that's a very valuable attribute of really decentralized apps. Their developer could disappear, and I think Gene was talking about this. Or no, it was Preston Bryan. If the Royal Marmot Army came and had a laser from orbit and it vaporized everyone who worked on the app, using all the info that's available on the internet, could someone else step in and start running the service again? And the goal of both of this is for it to be true.
Sounds like the kind of thing Preston would say. Did you think of your question, Rigidity?
Yeah, I was just wondering if ENS had a solution for the front running issue or if that's unique to Chia in some way.
No, they still do pre-commitments, so it's the same thing. It's called a commit reveal pattern. It's frequently used.
Yeah.
It's a simple deterrent for mempool-related issues. It has the drawback of user experience, which is you need two transactions instead of one. But I don't see any way to avoid it really without making sacrifices on the maybe decentralization front.
Yeah.
All right. Well, if there's no further questions, why don't we do catalog?
Okay, I think this will be a bit shorter. So as I mentioned previously, it's a shared on-chain cat database. And the idea is that if you have a token, you register it. And then as the issuer, you have the ability to update details about it. Also, there's these other entities called verifiers. So for example, if I display tokens on my website, I might want to be a verifier. So I check I carry the tokens that are displayed on my website because some might not be appropriate. Some I might just want to ignore because my website is specialized to category A in catalog of tokens, and catalog contains all possible tokens. Yes, and so the main idea is catalog acts as a shared database of details for cats that you can then reference on this layer of verifiers, and then you get the token details. It is hard to demonstrate you are the owner of a cat, and I'll talk about an alternative way maybe towards the end of the discussion, but the way you do it is pretty ingenious, although it has a few drawbacks, which is if you are the cat issuer, you'll have knowledge about the cat before anyone else. And that knowledge is the asset ID. So the way catalog works is that you essentially register the cat ID before you issue the cat. And because you are the first one to have known about the cat, you're considered the owner of the cat. And that gives you rights to update details. Now, this has the advantage that it works with all types of cats and tails. Yes, you can register invalid cats, but then you pay the registration fee. And the cat won't exist. Probably sites won't show it. Compared to XCHandles, you only have to pay the registration fee one time, and cats are forever. And that's because the owner of a cat might disappear. You will probably still want to keep the metadata of that cat around, just to reference. The owner can disappear and the cat will move on. So then it's up to individual websites to remove the cat if they only want active cats. Or what will probably happen is they'll sort cats by, say, trading activity, and then the cat will go lower and lower if it stops having activity. This rationale, okay, the first point is that this can use the same uniqueness mechanism as XCHandles. So you only register a cat if someone hasn't registered a cat with the same asset ID before. The registration will only enforce the uniqueness of asset IDs. So you can have two cats that claim to have the same ticker, but the realization of catalog is that it's just a layer that provides data, and then it's up for verifiers to arbitrage this. Because the blockchain isn't a very good judge of saying, hey, this ticker should belong to X, not Y. There could be someone that really, really wants to register USD. You have no way of preventing that with on-chain code other than a blacklist, but then who decides the blacklist? So this is a kind of a decentralized layer, and then the verifiers are the curators. So here, if someone registers USDC and says it's a meme coin, later Circle comes and wants to issue USDC on Chia, maybe the verifiers decide Circle has a claim to the ticker, even though the meme coin was first. So really, Catalog, the decentralized system, will handle resolving tracking registrations and resolving hashes to data. And then this kind of network of verifiers, which I'll get to a bit later, will handle these disputes. This just describes the existence of these verifiers. So the NFT that describes a cat, it will probably contain its ticker, and you have this SBX for spacebox. You have the full name. You have a description. You essentially have data for the interfaces that list the cat. Most will just use the name and an image. If you want the description, it's still there. You can use it if you want. I would say the interesting detail here is that we are adding a precision field. So by default on Chia, all cats have 3 decimal places, but that's only a front-end kind of convention. And if you keep adding decimals, it gets very expensive to mint a cat, to mint a high number of cats with those decimals. If you add less, if you have less decimals, it gets less expensive, but then you have less precision when dealing with a cat. So by adding an optional field that defaults to 3, cat issuer now have the power or ability to find the precision that has the perfect trade-off for them. And for example, if the bridge has milli-ETH, with this kind of backwards compatible scheme, all the wallets and interfaces that get the token but haven't adopted this precision kind of done, they would still resolve it as milli-ETH and see it as a token with 3 decimals. But maybe as the issuer, Orb.Green will specify that if they support custom precision, it should have 6 decimal points and then be displayed as warped ETH from base instead of warped milli-ETH from base. As I addressed before, the warped USDC.B will be used for catalog as well. And now the multisig only has the power to update the asset ID that the asset the payment is taken in, and the price. I corrected myself from asset ID to asset because the real pattern allows you to have cats or restricted cats, or maybe later cats with a fee. It's called a cat maker pattern. So it gives you more flexibility over which asset is taken. And of course, you can also decide to take the fee in XCH. Again, the multisig can set that. And there's just flexibility and upgradability for the future. Now verifiers, this is kind of the latest change, which is how do these verifiers keep the data? Initially, every verification, so every time they describe the cat saying, hey, I want to include this on my list, verified cats, they can also add kind of overrides there. So they're like, okay, I like all these details except the name, which I think has a misspelling. So instead of the name the creator set, display this other name on my website. This would have been a coin. In the current version, it's a data layer store just because it's more efficient to have batch updates to it. So if you want to verify 10 cats, your website that wants to display all registered cats, but you still want some kind of curation in case maybe their names are not appropriate or they are misleading. Now, one update means just updating the data store. To really build a powerful network, you'll probably also need sub-verifiers. So this is when some verifiers trust other verifiers. So a good example is, how do you handle Tibet's ubiquity tokens? Well, you could have a verifier and say they are displayed on TibetSwap, right? You could have TibetSwap curate all the liquidity tokens and handle all the images, make sure they are properly displayed. But then what if Verb.green wants to also show TibetSwap LP tokens? Curating the list themselves would double the work, and they already kind of trust the TibetSwap interface for other reasons. So they could set TibetSwap as a sub-verifier, and then Verb.green would have the ultimate say on which cats are verified and the overrides. But then if a cat is not found in their verified cat list, you go to TibetSwap and ask, do you have this cat? And TibetSwap would have the LP tokens curated. The registry itself is pretty simple because the logic on chain is so straightforward. You can register a new cat, and then you also have that refund action, because when registering, you're treating it like a handle registration. So you have that pre-commitment and two-step process. You also have the additional path for the future where the multi can update the pricing currency and the price. And all I said about XCHandles with Rue and the Chia Wallet SDK and the slot machine repository that contains the CLI holds for catalog as well. Yes, I will address this and then say an alternative design. A new security concern for catalog is that someone might not be aware of catalog. So they create a coin, and then someone says, hey, someone just issued this cat, but it hasn't been registered, so I'm going to register it. Now, catalog has no way of knowing what to do outside your interactions with the registry on chain. So it will just accept the new registration, and the malicious actor that just watched the chain has access. So the way this model prevents this is by having the verifiers agree to override the cat asset IDs. So if you're the real cat issuer and you don't want to reissue for some reason, there's always the option to reissue. But if you maybe already distributed your token and put it in a contract or something that prevents you to reissue it, you can just go to the verifiers that are active at the moment and tell them, hey, can you please overwrite all the details of my token with my real details? And now everyone trusting those verifiers will see the details you set instead of the ones in the entry of the malicious party. It's less than ideal, but it illustrates what verifiers are, which is kind of a dynamic social consensus engine. Probably the most popular websites will want to have their own verifiers or trust some very trusted parties in the system. But the nice aspect about the system is that this list can change and evolve over time. And then the websites that are in use can adapt by trusting new verifiers or keeping to trust the old ones. Now, I want to acknowledge Rigidity, STL, and Andres for providing a lot of very valuable feedback on multiple rounds of this. And also BremV for a lot of reviews. I will say the other possible design for catalog is having kind of a curated list of cats. So for example, of cat tails. So for example, most cats on Chia are issued with this tail that says, oh, this can only be issued once. So then you have a way to verify those, which is you show you have possession of the wallet that first minted it. And that's very nice. That has fewer kind of edge cases, like you can just now register it for catalog, and when you want it to show up, you're the only person who can show they have access to the wallet. The disadvantage there is that you have you have to maintain this list up to date. So when if all the people suddenly start having to do anything by singleton cat, which is another logic of tails, you have to respond and write another set of logic, another puzzle for verifying the new type of tail for catalog. And then you'd probably be okay with having like a maintainer at first and then transitioning to a more decentralized system. But I think this is a pretty significant drawback. And once again, this is open for the final choice for the logic is open for discussion in the chip. I am leaning softly against the one that's currently implemented, just from a theory point of view. And that's actually an idea Brandon / Rigidity shared recently. Yeah, I think those are the main discussion points. Once again, discussion is welcome. The whole purpose of why these are chips is because I hope to see them adopted in this ecosystem, and that means everyone should understand why they work the way they do, and everyone should have an opportunity to voice concerns, and maybe they see a better way to do things. And as past upgrades show, I'm very open to doing more updates if there is really a better way to doing things. But as this is the most polished version they have, and if no such situations exist, I think this is the best version of these registries that can be launched on Chia. So we'll proceed with launch. And with that, I'll take this chance to open the floor up for new questions.
Thanks, Yak. Questions from the audience? It was another very thorough presentation. So thank you for that.
Sorry for talking so much. I could talk about each one of these for hours. That was the compressed version.
No worries. It's your show.
I imagine it would be annoying to have to add every single kind of tail as they come out, as the like bridge multisig. You'd have to get a bunch of validators to agree to that every single time.
Yes, and yes, especially as Chia grows and there's more and more. I guess you could have a special kind where you add like one of tails. So if you, I don't know, if you have BYC and you know for sure that's the only token with that specific tail you want to verify, you could just whitelist it once and give the ownership to the to Circuit DAO. But then you still need a way to be keeping up to date. And I don't like that there needs to be this maintainer. And if they go online, the registry stop working. Because in this setup, if the bridge disappears, and then also the fee collector and everyone disappears, you can keep registering and trusting this registry. You just won't be able to update the price anymore. But also because there's the bridge multisig, it's 7 of 11 validators, and there's a lot of security procedures to make sure access is not lost to the multisig. So I think that's a very safe option for the beginning. And then, sky's the limit if Chia evolves and this gets a lot of attention and you start considering DAOs.
Yeah, I guess with a DAO, you could have a bunch of people vote in a decentralized way to add new types of tails.
If it turns out that the ideal logic is a lot better after launch, because it happens that some ideas just come after a while, you have no way to control for it. I think you can always design a new system, kind of import all the entries from catalog to the new system as a pre-mine, and then get everyone by social consensus to switch to the new system. It's just an operation that requires a lot of effort. So ideally, you get all the input before you launch, so you do all the possible improvements. But if it happens, it's a possibility.
Yeah, that's a good point. I think a good spot to end it with too, because this is where the discussion begins, and we want input for the community, so we get this right the first time, so Yak doesn't have to redo the whole thing. So, what you should do now, if you have any feedback for these chips, is leave comments on GitHub in the PRs. You can also discuss on our Discord in the chips channel. Any closing words, Yak, before we stop?
No, I just wanted to show if you're logged into GitHub, you'll be able to leave comments here. Feel free to reach on any platform. Yeah, thank you very much for your time.
Okay, thanks, Yak. See you
Thank
later.
you very much, Yak. Great presentation.